Thanks everyone for joining. This is reliable, secure, and efficient cloud operations. I am Kevin McGrath. I'm the VP of Spot by NetApp. We were acquired by NetApp about 2 years ago. You might remember us from in the past when we were called Spot Inst, seeing us out on the Expo Hall. We've been under NetApp now for almost 2 years, basically one pandemic. We've been, and that was an interesting run for us, I must say, going through that process during that time. But it's been really good, and we've grown up a lot. So if you know us from the past and you know us from where we came from, we're going to tell a little bit, I would say bigger story, more the evolution of where we've been going and the evolution of where we see CloudOps is going. So I'm going to try and do a lot of this presentation. I want to give you some generic, what is CloudOps? What do you just need to do whether you go with a vendor or not? Obviously, as Spot by NetApp, we feel that if you go with a vendor, your lives will be better and it will be magical and rainbows and unicorns and everything going forward. But there are some just basic principles that you need to know. So whether you use a vendor or not, getting into the cloud, how are you being efficient in the cloud? What are you doing with your cloud operations? I'll try and mix in both of those as we go along so everybody gets some good content by the end of this. So let's start out. Where are we headed in this cloud world is what we see is there's a lot of different names for this particular part of an organization. The new old name is now platform engineering. And platform engineering is starting to consume these different things that we've been talking about, I'd say over maybe the past 5 to 10 years, depending on how far back you go in the DevOps space, right? So DevOps, SRE, IT teams, really depends on where your company comes from, right? If you're cloud native, you probably started with the DevOps team. If you're a company that's been around for 20 to 30 years, you have an IT team. And you've had an evolution of what these roles are. And this is starting to turn into what's being generically called platform engineering. And this team has a really, really difficult job, right? They are on the hook for making sure that everything runs correctly in the cloud. And then when something goes wrong, they get called, right? And sometimes it's thankless. We try and thank them as much as possible, but they're working all the time. These are the people who are on call. These are the people making sure the lights are on. And they have a lot of different requirements, right? So not only do they have requirements from the application teams, right? Like, here's my application running in the cloud, right? Make sure it's running 24/7. They have security requirements. The CIO, the CISO, or someone is making up rules that they have to abide by and make sure that everything happens, right? So if a compromise happens in the cloud, who's the first person is the first person called the developer who pushed the code 4 weeks ago? Nope. It's that platform engineering team, right? They're on the hook, right? They're the ones who get the call. They're the ones who are responsible. Finance team, your CFO, your VP of finance, they're setting the guidelines for what the budget of the organization is. At the end of the day, who does that fall on to make sure everything in the cloud is running correctly? It's that platform engineering and that DevOps team, right? Now, they're working with other teams within the organization, but ultimately when it comes down and someone says, hey, cloud budget was over by X tens or whatever number of dollars for the quarter, the first person they go to is probably someone on the platform engineering or the DevOps team, and they say, hey, what's up? What happened, right? And so that team has to have tools. They have to answer for that somehow. And business teams, right? There's just general business requirements of how you do the business operations that you have within your organization. And there's a lot of responsibility that falls on this platform engineering team. And they have to organize their job, which is hard enough keeping the lights on, by the way, right? Especially when you're at scale. And then they have to negotiate with all these parts of the business, right? So this team is very, very crucial, especially as you get into enterprises and large organizations. How do you help this team be a superhero in their organization and not the one everyone looks at and goes, how do we get this done? How do we get this done? How do we get this done? How do we help this team turn around to the rest of the organization and go, hey, all the things that you want, all those things on the left that we see here, productivity, time to market, finance, governance, security, optimization, how do we say yes to all of those things so the businesses can focus on everything that's coming out on the right? And so that's what we're going to talk about today. And a lot, to bring it back to Spot specifically, our customers, we see this pattern repeated all the time. And granted, I'll go back, it's called different things in different places, but when we talk to organizations, eventually we end on verifying our product with a DevOps team, an SRE team, a platform engineering team, and they're the ones that we interface with going forward, them and the engineers, right? But mostly going through this type of team is really where we see the value in what you can do to unlock your cloud operations. So let's talk about that a little bit more. With cloud operations, you kind of need this holistic approach to how you go about it, right? You need to deploy, you need to operate, and you need to scale. And you need to do that, and you need to be secure across all three of these facets. And while you're doing it, the one thing that's extremely difficult is to optimize while you're doing this, right? So one of the best things that we got from DevOps very early on is this continuous motion, right? Every time you deploy, you want to learn from what you're deploying and you want to bring it back, right? So at every point, you want to get that feedback loop. And I think that's still the hardest thing that we need to do today. I think the hardest thing is stopping the point-in-time evaluation of what you're doing when you deploy, operate, and scale, and doing this loop every time you do it to get feedback to the rest of your teams, right? That's still the hardest thing that we have today. Especially when I talk with customers, I talk to people in the industry, there's still a lot of point-in-time analysis, right? There's still a lot of, hey, we'll evaluate where we are at the end of the month, or we'll evaluate where we are at the end of the quarter, and then we'll make decisions, right? The cloud is dynamic, right? We went to the cloud, not necessarily because of cost or anything else. We went to the cloud because developers and engineers had 1,000 endpoints that they could start manipulating at any point in time, and they could just get anything, right? And it's very dynamic, and it's very fast, and it's very fast to get stuff, and it's very fast to delete stuff. And that can be scary, but you can also use it to your advantage on a daily basis, right? And if you think about using that dynamic nature of the cloud to your advantage and stop thinking about it as a static number, then you can squeeze a lot more optimization out of what you're doing. So what is CloudOps, right? Cloud operations. So it's a few things. As I said, it's a holistic approach to how you build, how you deploy, how you run your applications, how you secure them. It's responsible for delivering and tuning and optimizing your applications in the cloud, right? It's all focused on the applications that you want to deliver. It's all about the SLAs, the SLOs, the error budgets. However you're managing it with your organization, how are you keeping to those KPIs that you need for your applications to run? It incorporates what we call DevOps, FinOps, and SecOps. We've all heard about it. We love putting ops at the end of every word that we come up in our industry now, right? But it's not far off. We do try and make the names very long, so like FinSec DevOps or whatever we got going. Whatever we got going. But it is true. DevOps is that practice of constantly deploying, constantly learning from your deploys. FinOps is that practice across your organization of understanding the financial impact of what you're building and how it's running and what it means to actually operate in the cloud. And then SecOps is a real thing too. What are you doing to continuously monitor what you're doing, how you're doing it, making sure you have the compliance and the security controls that you need to run your business. So they're all very important. We love when we find a cool name like DevOps. We started making cool ops names for everything else under the sun, but it's true. Like, we need to think about these things. And I think that's why platform engineering has really become a term that is trying to incorporate all of this together so we stop adding all the three-letter acronyms before ops, right? But they're all very important. And then I think the last thing that's super, super important, I keep talking about this, automation, automation, automation. Whatever you can automate. Cloud, again, is really big. Thousands and thousands of endpoints that developers can use at any point in time. That's a good thing, right? You want to move fast. Velocity is why we move to the cloud. Being able, to get an instance, in a nanosecond, right, is amazing. That's an amazing capability that we've developed over the past 10 years. I am old enough to remember when I had to rack my own server. Get it out of inventory, put it in, turn it on, and I know that's old hat for this conference, right? We've been talking about moving from the data center for years at reInvent. But it is true, that's the spirit of cloud. It's moving fast, velocity, deliver as fast as possible. That's why you're doing it. If you're not thinking about using cloud to move fast, you might want to rethink why you're in the cloud to begin with, right? Maybe now it's because of energy costs or something else like that, but really we moved here because of speed. That's why we're here. So very succinctly, cloud operations is at your organization how you think about empowering your organization to securely deploy, scale, and optimize your applications in the cloud, right? Very succinctly, that's what you have to do across your organization. DevOps isn't just a function of that small 8 to 10 person team in your organization. DevOps is a mindset that everybody has to have to move. FinOps isn't just the finance people yelling at the dev people to cut costs. It's a mindset everybody in the organization has to have. SecOps is not just the CISO and the security people telling everyone to be secure. It's a mindset everyone has to have. So when we talk about more of an application approach to how we look at things, you have your cloud infrastructure at the bottom, you have your cloud applications that are eventually delivered at the top, and then in the middle of that, you need a few things to run these. You need visibility. It has to be meaningful, has to be actionable insights on what you're doing. There is a lot of data in the cloud. There's more data. When you go up there, I mean, if you ever looked at a CloudTrail log for just deploying even a single application, right? Like, start spitting out all kinds of information, all kinds of great stuff we get, but the data overload is amazing. So having that visibility into everything that you're doing and using that visibility in a way that you're looking at what's important and saving or pushing away the stuff that's maybe less important so you can look at it at a later day, that's very important, and there's a ton of it. Automation, like I said before, you must automate. You cannot manually scale this and expect to still be fast. You have to be on an automation path. You have to have continuous optimization in everything that you're doing, and we'll get into that a little bit later in this presentation, how you can think about how you continuously optimize and what that means. Because in the cloud, you have this huge inventory of assets. How are you using those assets, not just for an application, but does the application need the same asset today as it needs tomorrow? If an application, we'll make a very simple example, if an application is running on a C4 10x large, I can't even remember all of them anymore, but if it's running on that during the week, does it have to during the weekend? Does it even have to be on, right? And then at scale, do I need 10,000 instances during the week, and do I just need 2,000 on the weekend, or is it the opposite? Do I need 10,000 on the weekend or 2,000, right? Like, how do you adapt to that? How do you make that work for your company? And then repeatability. This is super important. Over and over again, that cycle. Whatever you do once, if it works, you better be able to do it again, and again, and again, and again. And that goes back to automation. Because you can make all the run books you want in the world, but you'll end up with 10,000 run books. And it needs to be automated. You need to have a flow. You need to have a way to keep that going. So breaking this down a little bit more, we see this as three major areas. When we think about a platform engineering team and what they need to provide to their organization, we see this as a set of application services. These are fully managed services that the platform engineering team makes for the developers and other people within the organization to use. And we'll break this down one step further into what we feel those application services are. There can probably be a good debate about that, more or less, but we'll get into that later. Infrastructure optimization is very important for this team. Anything that those application services are running on, or anything that is running in the cloud, they constantly need to think about the infrastructure. Is it optimized? How am I optimizing that? And then operations automation, right? How are we using the data, the scale, the monitoring, the governance across all the deployments and everything that we do? And if you're hitting these three buckets, your platform engineering team or your DevOps team is thinking about this anyway, but you need to start thinking about this as an organization. And then bringing it back to Spot for a moment, this is where we focus, right? Spot by NetApp, we're trying to solve for use cases in these three buckets. This is how we make a platform engineering team more successful in their job and in what they do. So this is where we focus. And then you want to do this, obviously, across your AWS infrastructure, everywhere that you're running. So let's break it down one more. In application services, how do you deploy your applications, right? How are you thinking about that? Do you have CI/CD? Do you not have CI/CD? How does your team get your applications to the cloud? How do they start running? You need to have a platform. When you get to scale, you need to have a way for your applications to get from the developer's hand to production. It should be as automated as possible, but usually when you get to scale, you have a team that has set up a system to make that happen. There is a flow. That's going to be different in different organizations. There's a lot of different open source tools and a lot of different ways to make this happen. At Spot, we're not prescriptive, really, on how to make this happen. We want to hook in to the process that you have for deployment, and we want to be successful in that deployment process, because everyone has their own way to do this. Whether you're using the latest Argo CD rollouts, or whether you're still writing a bunch of scripts back in Jenkins, they're all valid if it works for your organization. But you have to think about how it's deployed, and usually that Jenkins or Argo CD system is set up by your platform engineering team. I'll move through the next two. All your applications need to use data, or most applications need to use data at some point in time. There's some apps that live on the edge that can process everything on their own. For a large amount of the applications that we see from customers, there's a database somewhere, and there's data streaming tools, and there's productivity tools, either workflow automation or things like that, that engineers and application teams need to use to make those applications successful. That same platform engineering team, usually they're on the hook for also delivering the database services and the data services and the streaming services and everything else that the application team needs to run at scale. A lot of times the application teams are sitting over there and they do a little test and they say, hey, listen, we had a one-node Kafka thing and we think Kafka works great. It's going to be good for the application. And then they got to work with the the platform engineering team to scale that. Maybe it has to actually be a 100-node Kafka cluster, or 1,000-node. Who's going to keep care of that, right? You need to have this work between the teams to make it happen. So as we talk about that, we get down into the next box, which is infrastructure optimization. So not only is this team helping all of your developers and your business deploy these applications to the cloud, but they're also making sure that the infrastructure is working well beneath. Is it running on containers? Is it running on VMs? What type of networking is it using? Storage, observability, how are you looking at everything? The connections between all the applications, how are those working and are those efficient? Are they talking across AZs when they shouldn't? Right? Is it sending egress data in and out when it shouldn't? Like, how am I being efficient? Are VMs scaling up and scaling down when they should? Are containers right-sized? Right? Are they asking for the right number of resources? Are we over-provisioning? Are we under-provisioning? You have to take all these things into account. Infrastructure optimization is super important. It goes to not only DevOps, but FinOps, right? And then in the last box, our operations automation, cost management, right? Like, this is getting heavy, right? Like, you feel this team, right? Feel the stress on this team. Not only are they're giving everything out, they're helping deploy, they're helping the databases, the streaming, they got a Kubernetes set up so you can deploy containers. They're trying to optimize all the VMs and infrastructure under that Kubernetes cluster. They're trying to keep it right. And now someone comes and goes, that's great, but you're over budget. Cost optimization, end-to-end visibility. How are users getting in and out of the system? Security, governance, compliance. All goes together, right? All of these disciplines are what you have to think about to have a successful CloudOps organization. And it kind of centers on what that platform engineering team has to deliver to the rest of the organization. But the rest of the organization is still on the hook. The rest of the organization has to realize what this team is doing and help them. Help them be successful also. And you need to have the tools to do that, right? And you can go out and get open source tools, you can get vendors, there's a million different ways to do this. But you have to have a solution for this if you want to be successful. So I'm going to get more into a little bit about how we think about this at Spot now. I'm going to get a little bit more Spot specific. Kind of went through the top level, high level generic, what you need to think about CloudOps, how an organization is set up, what that platform engineering team, that DevOps team is thinking about, all the different categories of where you want to be successful. I'm going to dive a little bit more into how we see this as Spot and how we try to solve this for our customers. So when we look at the cloud and we talk about visibility and we talk about continuous optimization and we talk about automation, what you get from the cloud is this endless amount of inventory to build your applications. And you want to use that to just give your applications the right amount of infrastructure at the right amount of time and then take it away when you don't need it anymore. And so when we look at this, the application needs line, you want that running right along with your scaling needs, right? You don't want that infrastructure to necessarily be below or above. That's the goal we're trying to get to. Now, do you get to 100% on this line all the time? No, but you want to stay within a margin of error of this, right? If the boxes on the bottom of that line go over, it means you're paying too much. If the boxes on that line go under, it probably means you're missing SLOs and SLAs somewhere. And this is the power of when we were a startup and our first product, Elastigroup. This is a graphic that's actually started, way back almost on day one of Elastigroup and is still here today. Because it's about taking all the different instances and infrastructure a cloud provider has to offer, matching that with an application need, and then getting out of the mindset of actually picking different instance types ahead of time, but allowing the application to define the infrastructure that it needs going forward, right? So if an application needs a certain amount of vCPU and a certain amount of memory at a certain price point, have automation that figures that out for you. Don't have a bunch of people in a room going, well, I think the application runs best on a C4 4X large, we'll scale up here, and then we'll have a policy when it hits X amount of CPU, we'll scale up and we'll scale down. It's actually not efficient. You're always over or under provisioning, usually over provisioning at that point in time, because everyone errors on that. But if you have visibility, you have observability, and you know what the application needs, maybe the application can run on a heterogeneous set of instances. Maybe the next instance that you scale up with is a M2 2X large, and then after that you scale up with a C4 10X large, depending on demand. Right? You have all these different capabilities, and then maybe sometimes it's a spot instance, sometimes it's a reserved instance, sometimes it's an on-demand instance. Right? You have all these different decisions that you can use in AWS. And I don't know how familiar everybody is in the crowd, but just to level set everybody, there's not just one way to buy compute. Like when you come to AWS and say, hey, I want an EC2 instance, there's list price, that's on demand, right? $1 an hour, I'll pay you $1 an hour. There's reserved instance, which is saying, hey, I'm going to run this. I'm going to tell you I'm going to run this instance 24 hours a day, 7 days a week, 365 days a year. And AWS says, great, I love that. If you commit to that for a year or 3 years, I'm going to give you a 35 to 50% discount. I forget where the numbers exactly are these days, but it's in that area. Or you can say, hey, I want to go to your spot market, and the spot market is this excess capacity that's not being used at this point in time, and AWS sells it for 10 cents on the dollar. Right? It's literally 90% discount on some of these instances, anywhere between 60 and 90, depending on the AZ in the region. Caveat of that is they can take those instances back from you at any point in time. Now, if you have a system that understands how to deal with that, how to deal with the dynamic nature of the cloud and the dynamic nature of instances and how that works, you can create an application that can use all three of these to your advantage. And where we really built a name for ourselves at Spot Inst, as you can tell, Spot Instances, clever name, right? We started to figure out like, hey, can you run production grade applications on Spot instances? And then how do we blend that with reserved instances and on demand? So when you're running your applications, normally people wouldn't run production or large grade applications on Spot instances because of the top graph. You have your required capacity, Spot market goes away for one reason or another. Now look, your SLA and SLOs are broken, right? Someone's getting paged, platform engineering team's hair's on fire, don't know what's going on. And then eventually you scale back up until the next time it happens and it goes back down. And at max you get maybe a 2-minute warning that the instances might go away. What we want to do is with all the data that we have is we always want to make sure you have the capacity that you need. So when we sense things going on with the spot market, we scale up. So you go over required capacity just for a little bit. So when it hits and it comes back down, you're back down to required capacity. So if you're using a spot market and you're saving 60 to 90% on instances, it's okay to spend a little bit more for a little bit amount of time, right? So for 15 to 20, maybe even 30 minutes, you're over provisioned, that's a good thing because you're still saving in aggregate. You got to think about, I'm running this application all the time. In aggregate, you're still saving a ton of money. So that infrastructure optimization is important. There's also other little nuances about this, like sometimes a Spot instance with a larger instance type is actually cheaper than an on-demand instance of the type that you actually need. Use the bigger instance, save some money, right? So it's about the application needs, not necessarily that you're completely utilized on CPU and completely utilized on memory, but are the application needs met with the infrastructure that you're providing, right? And so these are the decisions you can start making in the cloud, and you can start, it's not just squeaking out a little bit more savings, I'm talking about big chunks of optimization and cost savings that you can do when you get in a pattern of this. So along with Spot instances, there are RIs and savings plans. And with RIs and savings plans, you can have a method for managing those applications that can't deal with an interruption at all, right? So there are applications. We're not saying you can run every application on a Spot instance. You can't. If you have a database that you're running, or you have a lift and shift application that made it from on-prem to the cloud, sometimes they can't hit it. There's lots of use cases for reasons why you still need to run an on-demand instance that has the SLA of EC2, right? And for these instances, AWS has two constructs. They have reserved instances and they have savings plans. And they're both good for different reasons. Savings plans are kind of like an easy button. If you don't know exactly what you're doing, you can hit the savings plan button and you get it. RIs are a little bit more specific. You can generate a little bit more savings with them, and they're a little bit more specific to the region and the AZ that you're working in. But they both follow that construct that I talked about before, which is you're committing to AWS for a certain amount of time. Hey, I'm going to run this instance 24/7 by 365. AWS goes, that's great. I'm going to charge you for that on your bill, whether that instance is running or not. And it's actually what a lot of people don't realize is this is a billing construct and not an actual instance. So it says reserved instances, but when you buy a reserved instance, it doesn't actually tie to a specific instance in your environment. It's just a billing item. And whenever you launch an instance of that type, it'll hit that bill and get billed differently. In fact, you could have 3 different instances all hit a single reserved instance commitment in the bill. It's just they fill up that hours and then they move on, right? So they're going to charge you for these instances no matter what, whether they're running or whether they're not. Now, what we can do, one of the evolutions that we made at Spot is with Eco. So I talked about Elastic Group before, which is our original product. Eco was one of the next products that came out, and Eco helps you manage this reserved capacity. What we have with reserved instances is we also have a reserved instance marketplace. So if we can analyze everything that you're doing with your on-demand, your savings plans, and your on-demand instances, and we can pull all that together, we can use the RI marketplace to actually buy and sell RIs, right? So before I said you have to commit for a year to run an instance. Well, think about it. There's how many AWS customers out there, and they can all use this AWS marketplace to buy and sell RIs that they need or don't need. Now, there's a lot of rules and caveats around how you can buy and sell RIs in this marketplace. But if at 6 months your engineering team decides, oh, we're switching instance types, or we're going somewhere else, Eco can actually go to the AWS marketplace and find a buyer, right? And we can actually use our customer base at Spot, which is quite large, and usually we can figure out that transaction before it even hits the marketplace, but it all gets transactioned on the AWS marketplace. So now you can take these long-term commitments, these instances that have to run all the time, and you can make it a little bit more dynamic, right? You can start thinking like, hey, I can even be dynamic with my on-demand spend. If my needs are going to change in 8 months or my needs are going to change in 15 months, they can. I don't have to have this argument, right? That the engineers, the platform engineering team and the financial team don't have to sit down in a room and figure out like, oh, well, we'll have to run the application until May, when our certain cost advantage runs out, and then we'll switch over to the new instances and things like that. You allow your team to be fast, right? AWS comes out with a new instance type. You want to flip the reserved instance to a new one. Eco will sell off the old ones and buy the new ones. And this makes on-demand instances very dynamic. It allows your team to move fast, and it keeps the savings and optimization of the cost structure of what you're doing in the cloud at an optimal level. And then as we move along and we talk about applications, more and more and more of our applications are moving to Kubernetes. And Kubernetes has added another layer of abstraction, which we love. We love to do that in this industry. It's just, we're going to plop another thing on top of the thing that we thought was too complicated before, and we'll make a new one. But Kubernetes also has a lot of advantages on top of that also, right? It allows you to think application first. It allows engineers and developers to deploy applications that are defined by pods. Pods are a great definition and labeling of what an application needs. And really, to get this working in the best ways, you want those pod requirements and the labeling of what the application needs to define how it runs. You shouldn't have to care after you define how the application is set up, what it needs. You shouldn't care how the infrastructure is provisioned at that point in time. The last thing developers should be thinking about, and engineers when they actually hand it over to the CI/CD platform, is the specific instance type or infrastructure that it's going to run on when it gets to production, right? They should say, hey, this is a gold standard application. You know, in a perfect world, they should say, hey, if you have 3 standards at your organization, gold, silver, and bronze, this is a gold standard application. It's going to be deployed with these requirements. It gets this gold standard infrastructure, whatever that means for your organization, however it's defined, and it runs with the SLOs and SLAs that are hopefully defined by some sort of labeling mechanism that you have during your deployment cycle, right? And packaging applications in this way is very powerful. It can also be very non-optimal if you don't do it right, because, you know, I'm an engineer. If you can ask for more, you always ask for more. Or I used to be an engineer. My fingers to keyboard on the coding has gotten a little less over the years, but yeah, you know, how much do you need for this? I need all of it. I need all the memory and all the CPU. I want my application to run, and I don't want anyone to call me in the middle of the night, right? So think about it. Now you have requests coming in at a pod level, a vCPU, memory, different type of requirements coming in from the pod. That pod then asks for requirements from your infrastructure, from the instance, and that instance, you know, gets provisioned in some sort of scaling group. So not only could you be over-provisioned at an infrastructure level, you're over-provisioned at the application definition level, and you can be over-provisioned all the way down the stack. So you need to think about it, right? And what we want to do at Spot, when we came up with Spot Ocean, is we don't want anybody to think about that, right? We want a system where you take pods, deploy it to Kubernetes, forget about it, right? And whether you use a vendor or you don't, this is the same system you want in your organization. You want to know that Kubernetes is being continuously optimized. Some sort of system is watching it every second of every day to make sure the right decision is being made for the infrastructure that the application needs. And on top of that, that the application is being responsible about the memory and the CPU requirements and all the other requirements that it needs from the infrastructure. And you can automate this. And Ocean does this, right? Ocean takes everything that I talked about before, Spot, RIs, on demand. It takes into account everything that the application needs, and it puts all of that together so you can deploy pods to production and then forget about the rest. Like, if my application needs a GPU, it needs a GPU. Go find it. Go get it. Make sure it's at the best price point. Make sure it'll run for the time that I need it to run. If I need a certain amount of CPUs, go get those CPUs. If they have to be a certain generation, label it, right? I need a 6th generation. I need a 5th generation. Label what it needs. Ocean goes out and just finds it, right? Just goes and gets it. Now, you can put guardrails on it, and you can put configuration around it so it doesn't go crazy. But by default, Ocean's going to make sure it says, OK, this application has these constructs. I'm going to go get a Spot instance. Hey, this customer has a certain amount of RIs that aren't being utilized. We're going to use up the RI capacity, make sure that we get the best cost advantage for what we're already paying for AWS. Then, as soon as that RI capacity is, we're going to roll that out. And we're going to start using Spot or on demand, depending on what the application needs at that point in time. These decisions are being made every single second with Ocean. And that's how you can get down to that continuous motion, right? What I said in the beginning, where you're not making these point-in-time decisions about how you're going to deploy your application. There's a system in the background making these decisions for you, and then you check on the system. Is the system doing what we want it to do? Not are we reevaluating how we're deploying or how we're using our infrastructure every month to every quarter. So when we talk about CD, we want to talk about the same constructs. And Ocean has a partner now, Ocean CD, where we help people with this continuous deployment. And when we talk about continuous deployment, what we want to talk about is this full stack visibility to what you're doing and the continuous verification that the deployments are living up to the expectations that they are when they were deployed, right? So when you deploy an application, it should have a certain amount of SLAs, SLOs that it was supposed to meet. When you deploy that next version, if those aren't being hit, what's the decision process, right? So I deploy a new version of the application, it gets to production, all right, one of my SLOs is missing, or missing its target. All right, there's a decision point there. Roll back, provision more infrastructure, right? And there's probably a million in between. With Ocean CD, we want to start taking some of this guesswork out, or at least make it easier for you to troubleshoot and identify what's going on with the application. So we want to continuously verify that when a new version of an application is deployed, that it's acting like the old one, at least in the constructs of your business metrics. And if it's not, what needs to happen, right? Does a deployment need to change? Does a kube config need to change? Is it just a bad was it just a bad deployment and you need to actually roll back and do something else? Ocean CD will take care of a lot of this for you and will monitor applications through the process. So it'll say, hey, this is the previous deployments of your application. Here's the new deployment of your application. Something's off or something's good. Keep going or roll back. It'll also manage how you get this to production. Like, do you want to do a canary deployment? Do you want to do a red, blue-green deployment? And then it will monitor that and it will make automatic decisions for you. This is the next step. I think there's a lot of good constructs with canary, blue-green, other things. I think a lot of people still do these kind of manually. They do 10%, and then someone kind of checks on it a day later, and then they go, okay, I'm going to click it and go to 20, and then I'm going to go click it and go to 30. We want to take that out, that manual process. We want to alert when something goes wrong, not have someone have to manage a process as it moves, right? And our most recent addition to the Spot family is an acquisition that we did end of spring, beginning of summer, and open source data services. So when I talk about application services and where we were already headed as Spot, we did an acquisition of Instacluster. Some of you may know them already, but they do open source databases and data streaming services as a platform, as a service. And now we can add these data services on top of the optimized infrastructure that I've been telling you about, right? So we take these databases and these data streaming services and we build them on top of Ocean and we build them on top of Elastic Group and we build them on top of Eco. And not only that, with the power of NetApp brand, we can start taking these databases and use ONTAP underneath, right? And we can get all the features and the power of ONTAP, which is actually a really cool storage operating system, which has a ton of features that when it builds up into like a Postgres offering are very powerful when you talk about not only compute optimization, but data optimization with compression, deduplication, replication, all the things that we can do at a cool level with ONTAP, and all the cool things that we can do with Spot, and we put that all together, we can now talk about like, hey, how do we put together services so you can deliver Kafka, you can deliver Spark, you can deliver Postgres, Cassandra, and you can do that in an optimized way so they just become an endpoint, right? The endpoint for data is changing. Back when I started my career, the first thing you need to think about with a database is, okay, what type of frame am I getting, right? But nowadays, you just want to say, hey, give me my endpoint, and just like I talked with Kubernetes where I said, is it gold, silver, or bronze? Like, that's what I want. I need my production database needs to do X number of transactions per second. I don't care what type of storage you use. Just give it to me. Give me the performance I need at the best price point. And that's where we're moving with these open data services. And at Spot, we think it's very, very important to keep the data services open. When we work with Ocean, we do not change Ocean. We do not change Kubernetes. It is not a fork of Kubernetes. There's no crazy thing. We're not ripping the scheduler out of Kubernetes. We're not changing it or anything like that. We work with Kubernetes. When we deliver Cassandra, when we deliver Spark, it is pure open source. We optimize the infrastructure underneath. We want you to be able to use these open source tools in the way they were intended. Our focus is on optimizing that infrastructure so you make sure you're getting the SLAs of your application and the price point that you need to put it all together. Now to do that, we do everything below the line, right? And if your platform engineering team is doing this, they need to do the same thing, right? So if your application team needs Postgres, if your application team needs Cassandra, they're doing everything below there, whether it's managed or not, right? They got to do all of that. And they got to do it with the security and the compliance and everything. And that's where we step in. We say, hey, we're going to help you build that endpoint for your organization. If your organization needs Cassandra, we are going to help you. We're going to say, so you can turn around your organization. Yes, we have Cassandra because we use Spot by NetApp. That's what we like to say. If you don't have Spot by NetApp, you need to find another way to do it. But you have to do it. So we've talked a lot about deploying applications, scaling applications, the different price constructs that AWS has, how you need to think about it, how you need to think about being dynamic. Security is a huge thing. And we came out with Spot Security earlier this year for AWS. And how we look at it is we can't go to a platform engineering team and say we're serving all platform engineering team needs if we're not showing them a full CSPM outlook on everything that they're doing around their applications. You need to constantly analyze, detect, and remediate all of your governance and security practices in the cloud. You have to constantly be watching all this stuff, and it has to live next to how you're deploying your applications. And so where we've taken Spot Security is we've rebuilt what we think cloud native security is from the ground up, how you think about all the resources in the cloud and what's that graph or relational mapping of all the resources, and how when you touch one resource, how that spanning tree looks like, because it can go anywhere, right? Just one line in an IAM role can affect maybe hundreds of thousands of resources in the cloud, right? And you've got to know what that impact is for any point of your application. So when new things get deployed, or new services get deployed, or infrastructure gets changed, you have to have something that's also constantly monitoring your applications and your cloud security posture management. And so we also deliver this to that platform engineering team, and it's something that you need to think about. You absolutely have to have this. You don't want to be the next organization in the news, right? AWS is a shared responsibility model. Remember that. AWS does things to here. There you go. And here is the infrastructure, right? And they do a lot of work. They make sure the data centers are secure. They make sure, all the servers are built correctly. They make sure that everything is delivered to you in the SOC 2 or whatever certification that they need to give you that infrastructure. Once you put an application on top of it, everything from the infrastructure up is yours. How you configure an S3 bucket, how you configure a VPC, how you configure a security group, that's on you. They give you the tools. You have the responsibility. And so you need tools of your own to figure out how you can be successful with this. So everything that we do, you have to have the security hat on at the same time. And then, last but not least, before last reInvent, we did the acquisition of CloudCheckr. CloudCheckr is going to be integrated more and more into the rest of the Spot platform. It gives you that, whole sense. You need something that's going to give you that whole sense of visibility across every single dollar you spend. We talked a lot about scaling applications and very application-focused spend. There's a lot of other places your spend can go in the cloud. Where is that going? How is it being used? How is it relating to your organization, your groups? Maybe you're an MSP or distributor. How is that cost being allocated to your customers that you're supporting in the cloud? You have to have visibility into where everything is being spent, how it's being related, how it all comes together. If you can put together from the top down your visibility and your explanation for your costs and how you're using the cloud, and then from the bottom up, you can take the automation and continuous optimization, and you push those together, that's the magic sauce, right? And then you wrap the whole security ring around it, because security always gets added at the end. I don't know why, but it's always at the end. But security comes in, and when you put all that together, then you can get to a point where you're not only doing CI, you're not only doing CD, but you've implemented CO, right? You've implemented continuous optimization. So everything from the left, where the developer hits it from an integration perspective, continuously gets deployed, and then when in production, that application is still living. It's still a thing. It's dynamically asking for resources. We talk about immutable infrastructure, and I like that word because I think it's a good way to provision infrastructure, but we have to realize immutable infrastructure doesn't mean things are not dynamically happening in production. It just means an immutable configuration. That configuration needs to live somehow, right? We have spikes. We have different number of requests, different number of events. Queues fill up. They go down. All kinds of things happen. The production environment is extremely dynamic, even if you think it's an immutable config. So that continuous optimization cycle, how is the application scaling? How is it optimizing itself? How are you analyzing it while it's running? And then pulling that back into your CI/CD process is that kind of magic trick to get to CloudOps, right? And if you can put all these things together, then you're doing really well, right? You can be with confidence. You can look and you can say, hey, is my application teams or my DevOps teams, or is my infrastructure, is it as efficient as it can be? And can I focus on other parts of the business because I know this is taken care of? Because what happens in an organization is that you look at the costs, and where's the first thing you go is where the dollar ends, right? The dollar got spent on this instance, so everybody focuses on this thing. Whereas maybe that's not the thing. Once you know that's efficient, you can work your way back up the stack. Maybe my processes aren't good. Maybe we're doing something else in the business. Maybe our requirements for the application aren't correct, right? You can start focusing on other things. Once you know this part, you can take it out of the equation, right? You can remove that. You're going to know, I know we're efficient here. We need to optimize somewhere else. And you start having those cross-functional discussions within the organization to making sure that you're always available, you're always scalable, and you're always optimized. So with that, we're a little early, which is good. Actually, I went a little longer than I thought I was going to go. But yep, I'm Kevin McGrath. Again, Spot.io is where you can see all the great work that the team does at Spot. I'm more than happy to take some questions from the crowd.